Hello guys, I really appreciate you having opened this discussion about the elementary concepts of school mathematics. This is a very basic discussion on the ideas of angle measurements, treating inequalities, polynomial inequalities, and considering their solutions in terms of open intervals and closed intervals, and a query about what exactly is pi. I am not exactly, certain that you are quite clear about what these things mean when you use them while solving numericals or while solving problems. What I basically feel like is you should be absolutely clear about what these concepts exactly look like, are used like, and what do they mean. To begin with, the absolutely elementary idea about the angle measurements. Let's say we go for a simple circle. Let us say the circle has a radius r, and if suppose you take a thread, let's say you take a thread of length r, and you fix up one end of that at a position, and then tie up a pencil at the other end and move it around, you're going to get a circle. A circle of radius, say r. Aryabhat, the legendary Indian mathematician and astronomer, gave a very simple idea about how to calculate the length of the circumference of the circle. What he said, you take a thread of length r, or let's say L, you fix it up at one end and make the other end move, you get a circle. And then you take this thread length, move around this circle, and it moves six times around. It moves six times around. That means this length of the circumference is six times the radius, according to Aryabhat. And why exactly did he say so? It's because, we know that the circumference of a circle is 2 pi r. And what exactly is a pi? That we may not be knowing right now, but if you can recollect its value, it is 3.142857 bar. I mean, it's roughly 3.14. So 2 pi means 6.28. 6.28 times the radius means roughly 6 times the radius. You would have a very small angle left at the end of moving this radius along the arc of this circle 6 times around. A very small length would be left behind. And he used this idea in calculating the circle's entire periphery into 6 equal parts. Now here began the idea of 60 degree, 360 degree, and a basic idea comes up like this in standard measurements. Let's say I take this length of the thread and move it along the arc of the circle, and let's say I get this particular arc length, this arc length of the circle, this arc length, let's say that is equal to r. If this is equal to r, then what angle will it subtend at the center of the circle? The angle that it subtends is, let us say, theta. Then how do the arc length L, the radius r, and the theta relate? The L is always equal to r theta by basic relation of arc length with radius and the angle it subtends at the center. L is equal to r theta. Now see, if arc length is equal to the radius, that means if L is equal to r, then the theta value is equal to 1. Then the theta is equal to 1, and it's a pure unitless number. Here the theta equal to 1 is a pure unit number. It's a dimensionless. It is without any units. It's without any dimensions. It is length upon length. L by R is equal to theta is equal to 1. It's a pure unit number. Now that means if theta is equal to 1, this I can call as 1 radian. That means 1 radian is exactly equal to 1 as a pure number. Or we can also in short write this as 1 rad. 1 radian. We can also denote this by a C at the top. 1 C means 1 radian. We can also call this a 1 radian, and this is all equal to a pure number, pure unit number. This all is equal to this. And in terms of degrees, what does it exactly count as equal to? So as I said that if let's say this is 0 to 180 degree, if this is 0 to 180 degree, if this is 180 degree direction, the negative x-axis direction, then how many such angles fit over here? Now see, how many angles fit over here is not exactly countable, because this is in terms of degrees and this is a pure number. They do not correlate. The problem with the degrees and radians, why do we need radians when we already have degrees? The problem is something like this. Just as you cannot add 5 kilometers plus 2 liters, can you add this? No, you cannot. Similarly, you cannot say that 30 degrees plus half or 30 degrees plus 5. You cannot do anything about this. This is the basic problem with the mismatch of units. Degrees is a unit and radians are unitless. So that means there has to be a conversion, a relation between the two. And the conversion or relation between the two can be obtained when you count this angle, and this angle when counted comes up exactly as equal to 1 radian, comes up exactly as equal to 57 degree 32 minutes and 18 seconds. This is the basic relation between degrees and radians, and that means in 180 degree how many angles or how many radians we get. In 180 degree, how many 57 degree 32 minutes 18 seconds exist is exactly equal to a ratio which is called as pi. And this is one definition. This is one definition of pi. This is exactly pi, and pi is basically an irrational number. It is basically an irrational number. It is not rational, cannot be described in the form of p by q. The closest rational value of pi is equal to 22 by 7, or is equal to 3.142857 bar, and like that. This is the closest rational, not the exact value. Exact value of pi is something like this, and which is an irrational number. And this is how we define pi. This is one idea of defining pi. The second idea of defining pi is the second definition of pi. This is the second definition of pi. This is the first definition of pi. Now the second definition of pi goes like this. Circumference length of a circle divided by its own diameter. What exactly is the diameter length? 2r. And what's the circumference length? 2 pi r. That means this calculation comes up as equal to 2 pi r by 2r and provides pi as a calculation ratio. I mean to say, if you take a circle, any circle, circle of any radius, count, like, you take a circle, you put a thread over this and measure its length, exact length, end to end length, and then divide that length by the diameter length. You will get this pi. And in laboratory measurements, this has been found exactly equal. This has been found exactly equal. This is all about pi, dear. This is all about pi. You can say this is all, let's say this is all about pi. This is how it goes. Now, degrees and radians, right in this concept. Degrees and radians, as you can see. See, 1 radian is equal to this many degrees. Or you can say this pi radian into this many degrees is equal to 180 degree. So how do we go about converting degrees to radians and radians to degrees? It goes like this, dear. Suppose you say pi radians is equal to 180 degree. Hence, I can say, or simply say pi. Let's say pi is equal to 180 degree. That means 1 is equal to 180 degree by pi. This is how you convert a number to a degree. That means if I say I have to take 5, for example, if I have to consider 3 as a number, then 3 would be equal to 3 into 180 degree by pi. That means 3 would be equal to, this is 1, this is 1, this is 1. I am just a little lesser than 180 degree, and you say 3 by 3.142857 into 180 degrees makes you a little less than 180 degree. This is exactly 3 in terms of degrees. That means how many degrees are we talking about? 540 by pi degrees. 540 by pi degrees is exactly equal to 3. This is converting a number to a degree. Now we can also do the reverse. We can convert the degrees to a radian. That means 1 degree is equal to how much? Pi by 180. And that means x degrees is equal to how much? Pi x by 180 degree. And that means if I take 30 degrees, for example, if you take 30 degrees means exactly equal to how much? Pi into 30 degrees by 180 degrees is equal to how much? Pi by 6 radians. This is exactly converting 30 degrees into radians. Similarly, 90 degrees would be equal to pi by 180 degree into 90 degree, and that means equal to pi by 2. This is 90 degree in terms of pi. See this. This is exactly the conversion of degrees to radians and radians to degrees. You can do either way around. That's all about pi. That's all about degrees and radians. Let's go to the next part of the discussion, and that is about the intervals. Let's clear this out and let's go to the next part, which is about intervals. Now, while solving polynomial inequalities, I mean less than 0, greater than 0 situations, we can have some symbolic descriptions like this. Say this. Suppose I say x is greater than a and less than b. That means this is a case where the extremes have not been included. So if extremes are not included, then we call this as open intervals of numbers. A number ranging from little greater than a till a little less than b means x greater than a and less than b. This is a case of an open interval, open on both sides. And that means x can be written as element of a as the start of the interval with a round bracket means open, b as the end of the interval with a round bracket means open. This is how we denote an open interval. This is an open interval situation. On the other hand, if I take a case where x is greater than equal to a and less than equal to b, this is a case where extremes are included. Extremes are included, and then this is what you call as a closed interval. This is what you call as a closed interval. And how do you denote closed intervals? Is x is element of square bracket a, square bracket b, a closed, b closed, both closed. And this is how we say a closed interval looks like. Now we can have hybrids here, a mixture of the types here, something like this. Suppose you say x is greater than a but less than equal to b. How would you write it? When it's an open interval, it's a round bracket. When it's a closed interval, it's a square bracket. That means x is element of a open, b closed. This is how we denote the thing. This implies x is element of a open and b closed. Similarly, if we have a situation where x is less than b but greater than equal to a, that means x is element of a closed, b open. This is how we define intervals in math. This is the basic symbolic denotation about open intervals and closed intervals, and semi-open and semi-closed. You can call either of this semi-open, semi-closed. They are both semi-open, semi-closed. You can call this semi-open or you can call them semi-closed. That's all, dear, about these intervals, both of them. Alright, now let's go to solving inequalities on a number line. The last and simple part of the discussion. Suppose I have an inequality like this, x minus 2 into x minus 5 greater than 0. If I have to solve this inequality, just for example, this is just for an example. If I take this, x minus 2 into x minus 5 greater than 0, how do we do this? See my idea into this. You simply, first of all, take a number line and locate the roots of each factor. This factor has a root at 2 plus 2. Why I am saying so? Suppose if you write x minus 2 equals to 0, x comes up as equal to plus 2. This is a root. Similarly, x equal to plus 5 is another root. Now let's take a position on this number line. This is a number line for variable x. You take a position here. Suppose x is here. Now that means if x is here, x is less than 2. That means x minus 2 is less than 0. And that means x minus 2 turns negative. As a factor, it is negative. When it is negative? When x is less than the number you are considering it with. The root position lies to the right. X is to the left. X is to the left of the number, and hence x minus 2 is a negative factor. Now instead of 2, if I would have written 5, the result would have still been the same. If instead of 2, if I would have written 5, x less than 5, that means x minus 5 as a factor turns less than 0. The x minus 5 as a factor turns less than 0, that means x minus 5 as a factor turns negative. If x is to the left of a number, that related factor turns negative. That means to the left of 2, both factors are negative. Both factors are negative, and therefore the resultant of the polynomial is a positive. That means on this side, the resultant of the polynomial stands as a big positive. It's a negative into negative situation. It's a positive, resultant positive. Now let's take a position of x somewhere between 2 and 5, and you can see that if x is greater than 2, that means x minus 2 is greater than 0, that means this particular factor is positive. I have one factor positive here. And then if x is less than 5, and this is an ANDing, and if x is less than 5, that means x minus 5 is less than 0, and that means x minus 5 is a negative factor, and that means the other factor is negative. When you take the product, the resultant turns out as a big negative. And that means the product of these two factors between 2 as a number and 5 as a number is a negative. And then when I go to the right of 5, suppose I am here, if this is the position of x, then what? I am greater than 2, that means x minus 2 is greater than 0. Similarly, if x is greater than 5, then x minus 5 is greater than 0. That means both factors are turning positive. Both factors are turning positive in this zone, and hence the product is a big positive. And this is how we calculate the polarities of the product of factors in the intervals of numbers. Now what next? My requirement is that this product should be greater than 0. That means it should be positive. That means to the left of 2, I have my requirement fulfilled. Between 2 and 5, the product is negative. I cannot take this. And to the right of 5, I can take this. This is the solution set. And where exactly is the solution set? The solution set says that x is less than 2 or x is greater than 5. What exactly do I write here? From minus infinity till 2 open, because I do not have a liberty to be making this product equal to 0. And then again from 5 till plus infinity, that means what? I can write this in terms of intervals. X is element of minus infinity open, because I cannot take an infinity or a minus infinity position as a certain finite locatable position. They are never reachable and hence never equatable, and hence always open, never closed. Infinity can never be closed. They will always remain open intervals. So minus infinity till 2, and 2 is open. Union, or means union of 5 till infinity and open, like this. This is just an example. We can take one more example in this case. Suppose I have, let's say I have a product of 3 factors and we have inequalities. Then we can solve using the number line with a similar idea. Let's go ahead with that idea. Let's run it off and go ahead with a factor of 3 product of 3 linear factors taken together. And now I will not elaborate on the basic method so much as I had done so far. I'll just tell you how to apply it as in an exam hall. Say for example, I have x minus 2 into x plus 3 into x minus 5 less than 0. If I want to calculate this, see my idea. I take a number line. This is the x-axis. Locate the roots. Let's say this is plus 2. Minus 3, let's say minus 3, and plus 5, and let's say plus 5. And now see, when it is 3 root situation, I take a position to the left of 3. The entire number line has been divided into 4 parts. First, second, third, fourth. Now let's go to the first part. In this case, my x is less than each of the roots. Each of the factors are negative. That means three negative factors produce a negative factor. That means this side I am negative. When I cross 3 as a number and I have all the factors existing only once, that means they are linear factors existing only once. That means minus 3 until 2 plus 2. In between this, I have crossed minus 3. I have made this factor positive. My x now stands here and I am to the right of minus 3. That means this factor is positive. Let me make a table for you, for your simplicity. Just a moment. X minus 2, x plus 3, x minus 5, and let's make a table of the polarities as they exist region wise. Now here it is, x less than minus 3 is this region, and then x between minus 3 and plus 2, and then from plus 2 till plus 5, and from plus 5 ahead till infinity. Let's say this is the situation here. Now you calculate polarities. See this, and let's say here I write the polynomial p of x polarity. Here I write the polynomial p of x, and let's say this is your p of x. This is how we go about it. Let's see this. Now when I'm to the left of minus 3, when I'm to the left of minus 3, I am to the left of 2 as well, and therefore this is negative. I am to the left of minus 3, this is negative. I am to the left of 5, I am negative. Product, finally negative. In between minus 3 and 2, that is somewhere here, suppose, which factor turns positive? This factor turns positive. That means only this factor turns positive. Still, the other two factors, that is this and this x is to the left of 2 and 5 each. I'm to the left of 2, I'm to the left of 5. I'm less than 2, I'm less than 5. These two factors turn automatic negative. And then the product turns positive. And then the product turns positive. And that means here the product is positive. And here the product was negative. And this is how it is so far. Now let's go again. Between 2 and 5, you see this, between 2 and 5, that means I am standing somewhere here. And I am to the right of 2, I am to the right of minus 3. That means this factor is positive, this factor is positive, but this factor is still negative. And that means the product is negative. Now let's cross 5 and let's go to a position to the right of 5. Let's say I'm here, somewhere here, and I'm to the right of each of the roots. I'm to the right of minus 3, to the right of 2, to the right of 5, and that means each of the factors turn positive. Each of the factors turn positive. See this, and the product turns positive as well. This is how it goes. And then here to the right of 5, I'm supposed to be positive. And then how does the graph go? See this, dear. See, I am dealing with a cubic polynomial. In some other discussion, I'll mark my words. In some other discussion, you mark my words. I will discuss elaborately on graphs. And then you can see how cubic graphs or quadratic graphs or exponential or logarithmic or any other functional graphs go. And then the graph right now goes such that as I go to the negative side of x-axis, each factor turns more and more negative, and the magnitude is highly negative. It reaches a 0. It turns to a positive value, goes back to a 0 on the number line. It returns to a negative region and then goes back to 0 and then keeps going up. This is how a cubic function or a cubic polynomial behaves. And I require solutions for the regions where this product is less than 0, dear. That means my solutions lie exactly where? My solutions lie to the left of minus 3, between 2 and 5, and that's all. I require less than 0. I require negative products of these three linear factors. And I have one region and the second region. That means the solution set would go like this. X is element from minus infinity open till minus 3. Now, should I say open or closed? Oh, if I say I have an equal to here, then I can say closed. Now look at this. I made an equal to here and then I said closed. If I would say no, it's only less than, that means an open here, and this is how it goes. So let's make this equal to, that means let's allow 3, minus 3. And let's say this can be allowed and this becomes a closed interval. And along with that union, another set. 2 closed, 5 closed, oh yes, agreed. 2 closed, 5 closed, both closed. This is the solution set of this inequality. I hope you have followed. If you have followed, stay subscribed. More is coming. Thank you. See you soon.